So while we're on lockdown, I thought it might be of use to put up some short mathematical questions that people can explore. And so here is the first one. It's an integral. It's a definite integral. And what I would suggest you do is you have a go at calculating it. And on the next slide, we're going to have the answer and some comments on the answer. So have a go, explore it, and then you can see the answer overleaf. Okay, welcome back. Let's look at the answer. So, welcome back, and what I've done here is I've written out the answer. So, here is our integral, and 1 over x to the 3 halves means x to the minus 3 halves, and that means that we can use this integration formula, probably the first one anybody learns when they meet integration. So it just says that you take the power, you add 1 to the power, and then you divide by this new power. And for an indefinite integral, there is an integration constant. This is, of course, only true if n is not minus 1, because we don't want to be dividing by 0. And let's now use this rule here in the integral. So we add 1 to minus 3 halves. That gives us minus a half. We now divide by minus a half, so there will be a minus sign in front, and dividing by a half is equivalent to multiplying by 2. And this is the result of our integral, and we're going to work it out with an upper limit of x is 9 and a lower limit of x is 4, and there is no need to write the integration constant because it would cancel when you were to work this out. So, to work it out, I want to first of all rewrite x to the minus a half as 1 over the square root of x. That's going to make it easy for us. And now we just put in the upper limit, so x is 9. The square root of 9 is 3. So we have minus 2, and then that is divided by the square root of 9, so it's divided by 3. We then subtract and evaluate the same thing at a lower limit, and it is very good practice to immediately after this minus sign open a big bracket, because we're much less likely to make sign errors if we do things like this. So then at the lower limit, x is 4, and we have minus 2, and now we divide by the square root of 4. The square root of 4 is 2, so we're dividing by 2. So we have minus 2/3 first of all, and then minus minus becomes plus, and 2 over 2 is of course 1. So you might have been a little bit worried when you look at this that this is negative, and our integral we would expect to be positive, but we see now that we have from the lower limit a positive contribution which is larger than the negative contribution at the upper limit. So we have overall plus 1/3. And that's the result for our integral. And on the next slide, I talk a little bit about how one can bound this. And if you'd like to, you can see that on the next slide. So to discuss bounding the value of the integral, what I've done is I've sketched here the integrand, the function that we are integrating over, 1 over x to the 3 halves. And at the lower limit, this means we have 1 over x is 4 to the power of 3 halves. So that means it's 1 over the square root of 4 cubed, because after all, x to the 3 halves can be understood as meaning the square root of x cubed. So what we do is we have the square root of 4, that's 2 cubed is 8. So at the lower limit we have 1 over 8. At the upper limit in the same way we have 1 over 27. The integrand is above the x-axis, and you can see from this picture that its area is finite, so this is going to give us a finite positive answer, and the answer is equivalent to this shaded area. Now, calculating this area requires the use of calculus, the thing we've just done, but we can bound the integral in the following way. If I were to integrate 1 over 8 from 4 to 9, I would get the area of a rectangle of height 1 over 8 and base 4 over 9. And I've tried to sketch that here. So its base would be 5 because 9 minus 4 is 5. And its height would be 1 over 8 because you're going from the x-axis all the way up to 1/8. And that gives us an upper limit. You can see that this area is greater than the value of our integral. Similarly, a lower limit would be given by, well, the smallest value of our function is 1 over 27. So if we work out the area of a rectangle of base 5 and height 1 over 27, that's going to be less than the value of the overall integral, as you can see here. So our value for the integral, which we worked out to be 1/3, must be less than 5 over 8, because that is the area of this larger area rectangle, and it must also be greater than this smaller area rectangle, which is 5 times 1 over 27. So our answer is 1/3, and if our answer is correct, it must be between 5/8 and 5 over 27. And here I've just written out a little bit of arithmetic to show that it does indeed satisfy both of these requirements. And with that, I will stop this video.